Welcome back. We're in CV questions and problems. Problem number 1. If you're driving 110 kilometers an hour along a straight road and you look to the side for 2 seconds, how far did you travel during this inattentive period? Interesting. Now there's 2 ways that we can go about solving this, and I'm actually going to draw a picture first, and you should draw a picture too. It's generally a good idea to help us understand what's going on in these problems. Now in this problem, this isn't too complicated of a problem, so you probably could get by without drawing a picture here, but it doesn't take that long and it's kind of nice, and maybe it'll help somebody out here. So I'm going to draw a picture. So we have some velocity. It also gets us in the habit of doing really good techniques here of like, I'm going to draw the velocity. The velocity is going to the right in my picture. You could draw a picture where it's going to the left. It would be the exact same thing. It's going along here, and let's say that the 2 second period, let's say that we start time is 0 right here, and then wherever this is, we mark off the 2 second mark right here. And so our question is, how far does this thing go? That is a displacement there. So that would be a change in x, a change in position. How far is that thing going to go in the 2 seconds there, the arbitrary 2 seconds? So 2 ways that we can go about solving this. One, we notice that we have a mixture of units here. We got kilometers an hour and we got seconds. So notice that the time unit here, hours, is not the time unit over here that's in seconds. So we first need to resolve that. We need to either get kilometers per hour into kilometers per second, so then we can use the seconds, or the 2 seconds, and we convert that into hours. And either one will work. I'm going to use the 2 seconds and into hours. I think that'll probably be more straightforward for a lot of people. So let me go ahead and write down what we have here. We got 110 kilometers per hour. Okay, great. Now I need to go and use my time here. If I go ahead and like multiply this by time, the time unit would cancel out there, but I can't do that with seconds because seconds is different than hours. Okay, so let's go ahead and let's use the 2 seconds here. And let's see if we can convert that into hours. And I bet we can. And I'm going to give myself a little bit more room. So I'm going to move this thing over here. And I'm going to separate it from this guy over there. I guess I shouldn't have written that already. Can I get seconds into hours? Well, let's go ahead and let's see if we can do some conversions here. I know how many seconds are in a minute, but I don't know how many seconds are in an hour. But minutes would then get me maybe closer to hours here. I know there's 60 seconds in 1 minute. And the reason why I put the ratio like that is, check that out, if I make 2 seconds as a fraction, that's 2 over 1. Seconds is in the numerator here, and seconds would then cancel out with the seconds that I put in the denominator. That's why I put the seconds in the denominator, and I didn't put it in the numerator, because I don't want seconds as my answer here. I want hours as my answer, but minutes, you might say, is a little bit closer to hours in some ways, because now I could do the same trick down here. I'll put minutes in the denominator and hours in the numerator, and I chose that because you know how many minutes are in 1 hour. That's a general thing that most people remember there. And now my minutes cancel out in the same way. And notice this, when I do this multiplication and division here, I'm left with just hours, which is exactly what I wanted. So I go and I pick up my calculator here. And now I'm just multiplying these fractions here, as we normally multiply fractions, always straight across. So 2 times 1 times 1, and then divided by 1 times 60 times 60. And when you're doing this in your calculator, make sure you put parentheses for that denominator there. Otherwise, you'll be getting something else. And so now when I go and do that, I get something really small. I get something, my calculator says this, and maybe yours does too. It says 5.55, and then it does the little e to the -4. Now, if you weren't sure, I'm going to go rewrite that down here so I have more room to talk about it, 5.55. And then my calculator shows e -4. What the heck does that mean? Well, this is made up shorthand Texas Instrument calculator notation for scientific notation. This actually means 5.55 times 10 to the -4. And so they made up this little shorthand thing because they didn't have enough little pixels on the screen to write out the times 10 to the -4. Well, you're probably using one of the newer versions of the calculator that does have enough resolution on the screen to display that. Maybe it actually does. But the older ones that I grew up with and other people are still using today don't have the resolution to be able to show that, so they made up this little shorthand lowercase e. Make sure that you don't write that for any response, because that's completely made up by Texas Instruments and is not a mathematical thing or a correct way to be able to describe that. Anyways, you might still say, though, what the heck is times 10 to the negative 4? Well, that's scientific notation, and that just means that we've moved this decimal place over 4 places to the right. And so if I want to get this back into normal notation, I'm going to take that decimal place and I'm going to move it 1, 2, 3, 4, and I did it at an angle here because otherwise I'm going to run into this. I'm going to move it not here, not here, not here, not here, but over here, and then I'm going to fill in the rest, and I got to get rid of those other dots there, otherwise that's confusing. And then I'm going to fill in the other rest with the zeros here. So I'd have a 0 in between there, and a 0 in between there, and a 0 in between there, and always a 0 before the decimal place in the first place. So let me rewrite what that looks like. That looks like 0.00055. And now the 5's keep repeating there, so I'm going to put the line above it to indicate that the 5's keep repeating there. Okay, now that's in hours. So that's a very small amount of hours, and you should say, yeah, that makes sense, because 2 seconds is like, very, very quick, and an hour is a pretty good amount of time there. And so I would expect something to be very, very small like that. Now, what can we do with that? Well, our original 110 kilometers an hour, let's go ahead and let's do that down here. If I have 110 kilometers an hour, if I go and I multiply that by how many hours I'm actually going here, this 0.00055, and then repeating hours, I could write that as a fraction. I'll write it over 1. And notice when I do that, my hours are going to cancel out here, and I'm left with just my speed, just my kilometers here. So in my calculator, notice I don't put in these rounded values of 0.0005. Did I get enough zeros? Yes, I did. I don't put in the rounded value. I keep the entire answer, and I just take that whole answer and multiply it by 110, and I get 0.0611, and the 1 is repeating now, so I put that on top of that, and that's in kilometers. So it's that many kilometers. Cool. That's it. That's it. I'll add one more thing to this, and that is the fact that we know that velocity is equal to my displacement. Remember, delta x is the same thing as displacement over my time. And that is very similar to speed being equal to something divided by time, and that is not displacement, but distance. Now, speed and distance, we don't have shorthand letters for them because we generally don't use speed and distance that often. We use velocity and displacement very frequently. Well, here, our speed is 110 kilometers per hour, per 1 hour. And so that's going to be equal to some sort of distance, whatever that distance is, over some time here. And notice I can rearrange this. I can multiply both sides by my time value here. And time would cancel out on the right-hand side because time over 1, numerator, denominator there, cancels out. And now if I take my speed and multiply it by my time, I'll get my distance. I'll go ahead and rewrite that for you. My distance is the same thing as my time multiplied by my speed in this case, and I'll keep it as the 110 kilometers per hour. Notice that's exactly what we did up here. Here, the order of multiplication obviously doesn't matter. 3 times 4 is equal to 4 times 3. Maybe I should write that 3 times 4 is equal to 4 times 3, right? I'd still get 12 and 12. So it doesn't matter which way I'm multiplying these things. My speed here times my multiplied by my time is going to give me my distance here. And that's what I'm writing there. And that's another way, this is another way to be able to confirm that to be true. Cool. That's it. Have a beautiful day. See ya.